fractional parts of sets on our morning work this morning. And many of you guys did a great job. Edward, I saw yours. It was phenomenal. All of them were correct. So what we did was, what did we notice about all of the fractions, though, on our morning work? They all looked very similar to this, like 1/6, 1/8, 1/7. What do we call those fractions? There's this fancy math name for them. What do we call them, Gage?
Unit.
We call them unit fractions. Why do we call them unit fractions? What do they have in common? What do they have in common, Cherish?
A 1.
A 1 where?
At the top for the numerator.
Oh, say that nice and loud again.
At the top for the numerator.
Right. They all have a numerator of 1. They have different denominators. It doesn't matter what denominator they have, but they have the numerator of 1. So we easily found what 1/6 of 24 is. How did we do that? Somebody tell us what we do. First, what operation do we use? What do we use, Marissa?
We use multiplication or division.
You can use multiplication or division. Okay. So how would you, which one did you use?
I use multiplication by doing this. 6 times what equals 24.
Okay, so this is what Marissa asked herself. She says 6 times, I don't know, equals 24. And what was your answer?
4.
4. So what is another way we can do it? We had 2 different strategies because we're working with our fact families. What was it, Eliana?
24 divided by 6 equals what?
Okay, yeah. 24 would be our dividend because it's our total. We have 24 of something. And we're dividing up into 6 equal groups. Our denominator becomes our divisor, and this equals 4. So when we divide 24 into 6 equal groups, it equals 4. That's our quotient. So 1 out of the 6 equal groups is 4. So if out of one group, Edward, if I only have 1 out of the 6 groups, and it's 4, what if I now give you 2 out of the 6 groups? How many would that be? What would it be? Let's talk about, say I have candy. I have 24 pieces of candy, and I split them into 6 equal groups. In each of these groups, watch this. Here's my candy, all 24 pieces. Oh man, that's a lot of candy. 4, 8, 12, 16, 20. I need 4 more. I gave one group 1 out of the 6 equal groups to Eddie. But I said no, I want to give him more. Now, instead of giving him 1 out of the 6 equal groups, I'm going to give him 2 out of the 6 equal groups. Now, how many pieces of candy did I give to Eddie? These are all of my equal groups. Do you see this? How many pieces of candy did I give to Eddie? I gave him 2 out of the 6 equal groups of 24. How many?
8.
8. Right. Because I have 6 equal groups. Here's my groups in circles. 1, 2, 3, 4, 5, 6. And I gave him 8 pieces now. What if I gave him 3 out of the 6 equal groups? If I gave the whole class or something like that, I wanted to share 3 out of the 6 equal groups of candy. Then how many would I give out? What would it be, Mia? 12. What do we notice about these numbers? Let's read them out loud. 4, 8, 12. What are we doing there, Ava?
We're counting by 2.
So this number is increasing by 2 each time. When we increase by 2, if I increase 4 by 2, I would have 6. There's 4, 5, 6. Say that nice and loud again.
4.
I'm increasing by 4, Edward. Edward, do you see that? Because you like these fast tricks that help you solve the problems quickly. So if we increase by 4 each time, what would the next one be? Oh, I forgot my number there. What would the next one be?
16.
16. What's the next one, Cody?
20.
20. And then what's the last one? If I have 6 out of the 6 groups, I have what?
24.
24. Yeah, if I give 6 out of the 6 groups of 24 pieces of candy away, it's the same as giving them all away. Because we know that 6 out of 6 is equivalent to what? What is that fraction equivalent to? Yes, Leah. 1 whole is equivalent to the whole group of candy. Exactly. Now we're going to use this information. You need to watch very carefully because this is our number line today, and we're all going to be placing fractions on a number line in the same way. Of 24 is 4. 1/6 of 24 inches is 4 inches. So what I'm going to have to do, make sure that I'm on the inches side of my ruler because this is centimeters. We don't want to be on the centimeter side. All day we need to be on the inches side of our ruler. I need to start at the 0 and I need to measure how many inches away from the 0 mark until I plot the 1/6 point.
Work.
It would be how many inches? 4. All right, let's watch this carefully. Instead of just placing 6.6 slashes today, we're going to be very precise, and you'll see how this ends up. All right. Now, how many inches away from 0 would I plot 2/6? 8 inches away. Where would 3/6 go? Cherish. Next to the 2/6, but how many inches away from 0? 3/6 of 24 is 12. So how many inches away from 0? Not 3. What would you say? 12. 3/6 of 24 is 12. So it's going to be 12 inches away from 0. Looking at this right here, what would you guys say about 3/6? What other fraction is it equivalent to? Which one, Edward?
1/2 or 2/4.
Ooh, yeah, you gave me 2 of them. That was very nice. Yeah, it's right in the middle. And we know that all of these fractions in their simplest form is 1/2. So now that this number line is completed, all of these have the same denominator of 6. All right, I would like everybody to face this orange number line in the middle. We're not sitting on it, we're just facing it. Okay. This number line right here is 100 inches. We're going to put this right here to remind us. Alicia? Oop, that says 108. We're going to put this right here to remind us that it's 100 inches. Every group is going to be assigned a different set of fractions. And once you fill out this graphic organizer, you'll be able to easily put your fractions in the correct spot. All right. So where would 1 go? Can you go put it down there? Yep, you can pass it down the line. Where does 1 go? Great job. Some of you guys are going to be working with this number line, and others of you are going to be working with the number line over there. I'm sure you saw it this morning. This number line is 100 inches, and the second number line is 108 inches. But your fractions will work out well with both of them. All right. I'm going to call your groups. London, I would like you to work with Grady and Cherish. I'm going to get you your fractions. You need to be sure to keep yours all in the same spot. All right. There's yours. Make sure that everybody gets 1 piece of paper.
Work. No.
There you go. Ashton and Mia Davis, you guys are working together. You guys have a big job. You guys have 1/20th, which means you guys have 20 fractions to plot on the number line. But I know you can do it. All right. Bella and Ava. I would like you to spread out in the classroom and find a desk that you work with your partner. You guys are going to work right over here.
Can I see your paper?
And I would like you to work over here
Oh,
on
wowie.
and Eliana, okay? They're going to have an extra paper for you. Eddie's going to be in your group, okay?
Yeah. You only need one.
You have so many fractions to do. He'll be a good help.
These are extra.
We found equivalent fractions. What is an example of an equivalent fraction we found on this number line? What's another one, Cody? Yep.
20ths and 1/10.
All right, let's see where that is. We found 2/20ths is equivalent to 1/10. They're equivalent because they're on the same spot on the number line. What fraction do we see that has the most equivalent fractions? Where do we find that one? London.
At the wonders.
At the end.
Equivalent fractions.
All of our whole numbers, right, are fractions that represent them. What else did we find today as we were placing our fractions on? What did you notice, Marissa?
I noticed that some of them didn't go in order because the numerators 1, 2, 3, 4, but 5, 6, 7, 8, 9,
Okay.
and then 10, 11 goes 1.
So that's our rule with when we have the same denominator, the fraction with the bigger numerator is our larger fraction, right? Because our larger fractions are closer to what?
1 closer to
Right. Our largest fractions are closer to 1. Where are our smallest fractions? Our fractions with the least value. Cody?
9. Closer to 0.
Closer to 0. These are our smallest ones. All right. What is the way that we found that we can double check to make sure that we put them in the right spot? Did you find a way, Jocelyn?
Yeah, you could like cross multiply. Like if you think 2 20ths and 1/10 are equivalent, just put them next to each other and do cross multiplication to make sure, and it's correct because 10 times 2 is 20, and 20 times 1.
Yeah, show it. Show what you did.
So look, Jocelyn was over there at her number line, and she was checking everybody's work, and she's found some mistakes. And this is what she was doing. Show us.
I did 10 times 2 is 20, and 20 times 1 is 20, so they're equivalent in the same spot.
So they passed the test. So what if I had, like, these two in the same spot? How could we figure out that we were incorrect, Jocelyn?
Because if you do 20 times 1 is 20, and then 4 times 5 is 20, so they will be equivalent.
So we needed to move them back over. Did we find any other patterns with our fractions? Because I found my pattern that when I was working up here, I was counting by 4s. 4, 8, 12, 16, 20, 24. Did you find a pattern on yours? What was your denominator?
Mine?
Uh-huh.
My denominator is 6.
So what were you counting by?
I was counting by 18.
You were counting by
Like
18.
I did 18 plus 18 equals. What is it?
It was what?
And then after the 18, we did 18 plus 18 equals 36. And
then-
36 plus 18 equals.
To the next number.
Yes.
So you continue to add by 18 all the way. Those were great findings. All right. We found many great things as we did this. You guys did a fantastic job. We're going to continue to look at fractions on number lines tomorrow, too. Thank you for your hard work.